Hello, and welcome to Sneak Live, in particular, a stranger danger session for you today. Hope you're having a great day wherever you are in the world, and thank you for tuning in and joining. In particular, this stranger danger is going to be focused on containers, and it's going to be about why you, as a developer, should, yes, you should care about container security. And I am not somebody that is an expert in this, but fortunately for all of us, we have somebody that's joining us today that is an expert and going to help us learn more about what it is we should be thinking about as developers when we're using containers for our apps and services that we're building. So, without further ado, I'm going to bring on the one, the only Eric Smalling. Hey, Eric.
Hey, I'm not the only Eric Smalling, actually.
You're not.
My
Oh,
first Facebook friend ever was Eric Smalling. I had an
wait.
account I never used back in the early days, and some guy named Eric Smalling friended me. So there's at least two of us in the world.
Wow. Today I learned. Okay. Well, now I know. There's definitely plenty of Brian Clarks in the world, so I can't ever really say that. It's very common.
I
So,
I think there's a soccer, or as you say, football player named Eric Smalling as well. But I am nowhere near that famous.
as I say football, I mean,
As
I'm in
as
the
as as you say, just
as you say,
as we
okay.
should say.
Yes, yes, yes. Okay, great. So, Eric, what are we, so what are we like, why, listen, containers are cool. I see great value in them both as like a development environment and also for deploying and pushing to production using them. But like it should be just it's simple, right? Like I just set
Oh
up
yeah,
my container, Docker file, and I'm good to go. That's all I need to worry about is
oh
like
yeah,
as long as
silver
my app
bullet.
runs.
Total silver bullet. No worries now.
Yeah.
Well, that's what we're going to talk about today, Brian. We're
Oh,
going to get into, what is it about containers that, as a developer, so I have a developer background, and when I started containerizing things, I thought it was, oh, this is just like VMs. It's not. And there are things you got to start thinking about. That's what I'm going to get into. I'm going to show you what can happen if you don't.
all right. Well, I'm excited to learn more about this because I need to level up in this department, and I appreciate you coming in to show me that.
Awesome. Let's get going.
Cool.
Okay. Let's see. Let me get my screen going here. Oh, you got it. Look at you.
I'm on top of it, brother.
StreamYard is I love and hate StreamYard. I will get used to it eventually. So today, Stranger Danger Container Edition, or as I also call it, why developers should care about container security. So just to give you, if you've not seen me before, a little bit of heads up of where I'm coming from. I'm a senior developer advocate here, and I'm in the North Texas area. I've been doing software development for 20 to 30 years, depending on how you look at the role. Did a lot of work here in the travel industry, various companies around DFW. That's kind of one of the main industries here. And a lot of Java work, a lot of Python, C++, things like that. And the last decade or so of my career has been, other than the work I'm doing as a dev advocate now, was around consulting in the what we would call today the DevOps space and build automation, test automation. I was the Jenkins ambassador for a little while. I was instrumental in setting up a lot of um, high volume, high scale Jenkins servers at a couple places around here. So I've been around the block. I got introduced to containers in Docker in the early days, back when pre 1.0, back before we had orchestrators or even Docker Compose or anything, and took to it immediately. It was a great way to encapsulate things, lightweight. And recently, I was added to the Docker Captains group, honored to be part of that team. And I've gotten all three of my certifications, although I'm about to have to retake my CKA because it's about to expire. But that's enough about me. If you care, you can follow me on the socials. It's at Eric Smalling. I usually post slides after I do presentations like this, so watch for them there. Today's agenda. First, we're going to talk a little bit about what is DevOps and how does security play with it or not. And then we're going to get straight into the meat of this with what are the challenges we as developers face as we containerize our apps and specifically around security. Then I'm going to show you a demonstration of what happens if you're not paying attention to that, or what is the downside, I guess you could say, um, and some mitigation efforts around what you can do to protect your applications and be more secure. And then finally, you'll wrap it up. And if you have questions, we will be watching. I'm going to open that up in my other monitor here now so I can see them if they come in. And Brian, I'm sure you will help me out with that as they come in. And
Yeah, I got you
actually, I got to
covered.
shut my door because if I don't, somebody from my family will just walk in their pajamas, and that will be okay. Sorry. So get my focus back on my slides. So DevOps, what is DevOps? Unfortunately, for a lot of people, this is a buzzword, and a lot like if you've been a developer as long as I have, Agile turned into that for a while. It became a product for consultants to sell you. I want you to kind of go back to what DevOps originally was meant to be. This is the combining of development and operations into a cohesive team that works together. And there's technologies, there are tools, there are practices around that is way out of scope for the discussion we're going to have. But I'm not talking about a tool when I say DevOps. I'm not talking about a particular methodology or anything. I'm just talking about the main cultural meaning of DevOps. And honestly, when we think about DevOps, we often will think about continuous delivery. If you've read the classic book by Jez Humboldt, and the SDLC, software delivery lifecycle pipeline, comes to mind. And I like to put it up here because most folks that are doing iterative development with a CD mindset are dealing with a pipeline, something like this. This is very simplistic, obviously. On the left, you have starting from ideation, which isn't really represented, but then initial walk into this for most developers is when they get a ticket and they start coding. And then you work through, if you're doing like a pull request style branch system where you're doing a branching, you do the tests on that, you pull request that into your repository. And then finally, your CI/CD systems build and test and do their things. And eventually you end up in production on the far right. Now, obviously you'll have more or less steps depending on your organization. I've added our little patch the dog logo on here in the places where security historically has been talked about. And production is kind of table stakes. We've always had security concerns in production from back in the 90s. We you firewall off your servers. You have role-based access control, hopefully, on who gets access to those servers. You do all the things. You have tripwires and whatnot, hardening your servers so that not just anybody is able to get on there and do what they want. When CI pipelines and CD pipelines started to become popular, a lot of security tried to add themselves in here, and they did, but they were usually a late stage in the pipeline. They were either manual gating that would happen, and AppSec teams or other teams would come in and do an audit of a release before it goes to production. And because this was a manual process, it usually happened after most if not all the functional testing was done, performance testing. It was one of the last steps. It was in and amongst that. And the problem there would be if they found something and they had to get it remediated. Now they got to pull the cord on the line, stop everybody. The developers had to reset their brains back to the context they were in when they made changes around that area of the application, just like any late found defect. And other reasons that late stage or that security could be at late stages, if it was automated, there was oftentimes tools that would take forever to run. Maybe they took overnight to analyze your release, or they were onerous licensing concerns that caused it to only be able to run on specific servers in your CI cluster, or things like that. Well, as time went on, security started to, as we say, shift left on the pipeline. And when it comes to containers, we see vulnerability scanning start to get added to your registries down here at the bottom, which is when you push an image up to a registry is what stores the repositories of images and tags. Scanning would happen as things came in, or maybe even in your repository itself, you might have some kind of action that could happen that would do a scan. And this is great. Moving it closer to the developer and not being such a late stage gets you faster feedback, which is the goal of CI. But oftentimes these would just spit out a big, basically, spreadsheet of CVEs. Like, hey, developer, thanks for your build. Here's a bunch of vulnerabilities. Have fun with that. And unfortunately, a lot of time the developer like, I have no idea. Somebody else that cares about this will deal with this. And not that I would ever have said such a thing, but As we move forward, the same kind of tests could also then be run as part of your pull request process or your code review process. So we have automated code reviews started to become popular in the late 2010 area, where a pull request would come in and you'd have functional smoke testing maybe and PMD or whatever you use for quality analysis. Well, you could potentially put security testing in there if it ran fast enough and can be used there. Finally, where we are aiming for, where what is the holy grail, if you will, would be for security to be applied not only in these places, because it's great to have them here, but also right on your workstation, right as you're coding, to be able to have tools that are fast enough that can give you feedback immediately before you even push to your code branch or your repository or GitHub or whatever you use. And in addition to being fast, having it be information that I can proactively use, even if I'm not a security expert, something that I can use to either fix the problem because it makes enough sense to me, or that I can take to my teams and say, "Hey, here's an educated discussion about this," instead of, "Hey, there's a list of problems," right? So, when I show this, sometimes people, this is what we would call DevSecOps, right? This is where you're making sure security is part of ops. And honestly, DevSecOps, I'll get differing opinions even from my colleagues on this, but is not really a thing. It's more of a clarification to make sure security is part of your DevOps story. In fact, I remember seeing Gene Kim, the author of the Phoenix Project and other such books, do a presentation years ago where he actually had a regular expression there because it was Dev QA ops, Dev this ops, Dev that ops. It's Dev everything ops, right? But security is one of those everythings that needs to be taken account of. And when some people see this, they say, "Well, you're bashing on the security teams. It's not their fault. They're late stage." It's like, no, it's not their fault at all. They really, when we went to this highly iterative, highly automated CD process, in many ways, us developers and operations, we didn't invite them to our party. And having them be team members instead of this late stage policeman person that is going to hit us over the head with a club if we do something wrong. We want to get rid of that point of view and actually have them, us all working together, which is what DevSecOps means. So enough high level stuff. Let's get into the meat of this. Container challenges. So what are the challenges we face? First, containers, as a developer, this is an increased scope of responsibility. Historically, we know we need to write good code. We know we need to pay attention to the libraries we're pulling in. We have, entire architecture towers that determine what we're allowed to bring in. We have tools like, if you're a Java developer, you might be using Maven or Gradle, and you've got library registry mirrors that are managed and make sure that they're proxying only the things you're allowed to have. All of that stuff is important. We know that. But as we start to containerize, we're now starting to take on operating system level concerns, things like packages you're bringing in through a package manager, or what operating system distribution to choose for your base image, user permissions, file permissions, all that kind of stuff, which we know about as developers. It's kind of, you get that, but oftentimes and historically that's been handed to us by either our security teams or our sysadmins or other people have said, "Hey, here's the environment for you to work in. Make your stuff work there. You write a WAR or a executable jar that fits into this mold." Well, with containers, you have a Docker file now that more often than not sits right alongside your code, and it is a kind of code. It is code. It's a building of a small infrastructure, if you will, around your application. And while we usually will have help from those teams in picking distributions or whatever standards they might have, it can be daunting to look at it and say, "Well, I don't want to screw it up, so maybe I won't touch this one. I'll leave that ticket to somebody else to work on." So we want to, this is just a whole new scope of responsibility. And the reason why it can be daunting is because, to be blunt, if you're new to containers, you probably have a lack of expertise in operating system level concerns and file system stuff. Because, as I said, you've had middleware teams or other teams that did a lot of this for you. And all along this journey to continuous delivery nirvana, the whole point of that is to increase velocity, to get from ideation to product in front of customer faster and with higher quality. adding security to the developer's workflow needs to be something that maintains, or honestly, the business would probably like us to continue to increase our velocity. We can't negatively impact that velocity. So when we talk about applications, or if you're, some people would say services, if you're in a microservice type situation, we understand that, what is that made up of? We code, obviously. So here, we have a Flask app. It looks like here in Python, and then the requirements of that code. That in this case, we've got our probably PyPI requirements coming in, or this was Java. You might have your Maven dependencies. Fill in the blank. Go modules. We know that we need to be picking good modules, good libraries that are not vulnerable. That makes sense. Well, now you have this Docker file, which I just mentioned. And in this little, example screenshot, we're looking at a Docker file that starts from Python 3. Okay, well, I get that that's a Python 3 image, but what distribution is it based on? What version of Python 3 is it? What that stress ng that we're getting, that package, what is it? What is apt-get, and what does it mean that I'm getting that? Am I doing that correctly? All of these kind of questions start coming up. Then we have, on top of that, you might be dealing with infrastructure as code, like Terraform or CloudFormation, and the complexity of that alongside your code, trying to make sure you're wiring all of your cloud services together and whatnot. And then finally, if you're in containers, it's very likely you're dealing with Kubernetes, which is a whole nother API that changes 3 times a year. And knowing what are the best practices around how to wire all these containers together. What do I need to be setting as far as security contexts or limits and resource on the resources my containers use? Network policies. How do I make sure pods are talking to each other or not? All those kinds of concerns come up, and it's enough to hyperventilate just getting your app to run, regardless of making sure it's secure or not. So at this point, I just want to throw out an example of what can happen, and I'm not singling Capital One out here, because Capital One they're amazing. I have a lot of these folks here in town with me that I've met before. They are top tier developers. They know what they're doing, but they did have an issue that was quite prolific back in 2019, where not to go through the minutia of it all, but they had I've heard anywhere from 100 to 150 million dollar loss to both both in fines and lost revenue based on lost business, because of a perfect storm of application vulnerability, configuration problems with web application firewalls, cloud configuration, all sorts of stuff all came together. And these slides will be available. If you want to read about it, you can go to the article that's linked here. But what it comes down to is that these distributed systems we're working on today are highly complex, and oftentimes many of the components you are having to use, you don't own anymore because they're cloud provided or they're owned by another department in your company. And a misconfiguration on any one of them can lead to a domino effect, and an exploit can happen like this. So enough slides. Let's get back into a demonstration, or let's get into a demonstration. So hopefully, you're seeing oh, you shouldn't see that yet. That's a preview of what's to come. Let me get an open terminal here, and we're going to take a look at what we have. Let's set the scene. So we're at a company that is a J2EE Java shop, and let me show you the Docker file for the application. So this is a simple Docker file. And it starts with, it's a multi-stage Docker. If you're not seen this before, the Docker file is what builds an image. An image is what is the basis of a container, roughly. So at the top, we see from Maven, blah, 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 as build. This is saying this stage is where I build my app, and I'm giving it a name of build. We do a Maven build on the thing. Ignore the skip tests. I'm messing with this thing, and I've broken my tests. So that wouldn't be there in a real world. Demo world. And then the final stage, this is what actually creates the image that's going to run as a container. It starts from the official Apache Tomcat image at 8.5.21, and we set a couple files up and copy some artifacts from the build. That's where you see these from builds. Basically, we're saying take these things from the Maven, the build stage, bring them into this final image, and ship them out. So when we see that running, let me get to my browser. So here's the top level of that Tomcat server. I'm just running locally with Docker Compose. I'm not doing anything fancy right now. If I were to go to the context of the app, you'll see there's our beautiful to-do list app. It's award-winning. But honestly, for this example, I'm going to stick here at the top level of just Tomcat itself. So um, putting aside application security concerns, this version of Tomcat, which if you know anything about Tomcat, this is a very old version, has a vulnerability in it. So I'm going to put my black hat hacker hat on now. And when don't have my bookmark open, excuse me while I pull up something here. Where's my folder of bookmarks? Just going to open. Just open. Sorry. As a hacker, I'm often looking through release notes for software, operating systems, whatever. And I notice in Apache, Tomcat 8.5.23, there was a remote code execution exploit that was repaired or fixed, gotten rid of. And that tells me that, that anyone running 8.5.22 or earlier would potentially be vulnerable to this. If I click through to the CVE, I can, if I was really nerdy, I could get in here and start. Oh gosh, this is gonna apparently MITRE is there it goes. I could get into this and look through all of the minutia of this and try to figure out what it is. But let me show you on Snyk. We have our own vulnerability database that you can look at. And in that one, there's actually a bunch of information here that's a little bit easier for developers to look at. So if I was looking at this, trying to research, hey, is this vulnerability going to impact me? It'd be great. One of the links we have in here is to the exploit DB, which is where a lot of security analysts will put proof of concept code. And sure enough, we have a Python. Oh, this is actually the wrong one. Live demos, folks. I normally have all my tabs set up for demos. Sorry about that. Here we go. This is the Python script I'm looking for. This is the Python script that has a couple of functions in it that will check for and do a proof of concept exploit for this particular remote code execution exploit. And remote code execution means run code on somebody else's remote server, execute that code out on somebody else's server where it shouldn't be. So I've taken that script and I've imported it into these tabs. Here we go. And I've put it behind an alias of check. So imagine this was some kind of like war dialer kind of situation where I'm just going around the internet looking for open web servers that respond to this script. And this script, in this case, since I'm running locally, I'm just hitting my local IP. And it has found that port 8080 is vulnerable potentially to this exploit. And if I go back to my browser and I add /poc.jsp, you'll see that I promise you that was not there a second ago. It has injected a JSP into the Tomcat container, not Docker container, but the Tomcat web container. And in this case, it's just a bunch of A's. There's nothing really nefarious about A's, except for the fact that I just pushed a JSP into somebody else's Tomcat server. That's not good. So I come home after a long day of whatever hackers do, and I find, oh, here's a potentially vulnerable one. Let's actually shoot the proof of concept vulnerability into that. And we'll come back here and we're going to change POC to PWN. I get this little field here and I can type, let's say host name. I'm now running commands on the server that's running that Java application. I am executing a remote code execution exploit. That's an interesting host name. That tells me that this might be something like a container. And sure enough, I do an env, I can see all sorts of interesting things. Tomcat Made. I know I'm running on Tomcat 8 on Java build of that. So all sorts of information is coming out here now. And let's see, what else could I do? Let's see, who am I? Oh, I'm root. That's handy. Always good to have root access to something. So I wonder, do I have curl on this machine? Let's try to go to google.com. I got a 301 back. That's a good sign, actually. That tells me, A, curl is available to me on this machine, and I have internet access because I was able to get to Google. If I can get to Google, I probably can get to anything I want. Let's go for gold here. Let's see if I can do this. if I'm root, I should be able to do things like this. Ah, cool. I can install software. So I could go on and on. But at this point, I'm probably curling down my hacker script from S3 bucket XYZ to do Bitcoin mining or to start expanding the blast radius of this exploit to further exploit this. One of the tools a lot of times you'll see used in my demos at least would be, can I get Nmap onto this box? Since I'm root, I can run Nmap, and Nmap allows me to start querying the network around this container and see what else is out there to get at. Another thing to look at, let's see if we can touch a file somewhere that we shouldn't be able to. There's no output of that, so let's do ls-ltr of Etsy. And at the bottom, sure enough, I was able to create a file in the Etsy directory of the root of this container. That tells me it's a read-write file system as well. That which I kind of got because the apt-get worked too. So a lot of stuff I'm going on here. So at this point, hopefully, if you go back to my original graph in your mind, the production side of the house is getting flagged. Some things are happening that shouldn't be happening, and intrusion detection alerts are going off. But wouldn't it be nice to be able to head this off ahead of time? Like I said, all the way shifted left to the code side. Take a look at how we can do that. So I showed you the Docker file, and let me scroll. Well, I'm just going to show you this. So we have a scanner, Snyk container test. It's also baked into Docker. So if you're using Docker on the desktop or at the command line, you can do Docker scan. It runs our same scanner in the background. This is gone in and it's showing me all of the vulnerabilities that it's finding in my image. I ran this ahead of time for time's sake. It takes about, depending on the size of your image, it takes anywhere from like 10 to 30 seconds for an average sized image. What it does is it scans through, it takes the image apart, looks through all of the packages that are installed in it, and then kind of forms an internal bill of materials and starts querying our vulnerability database for the current state of things. So it's like, I've got, let's say, what's this one? I've got IP route 2 at 49011. It says, is there anything wrong with that? Is there anything wrong? And it gets all of that data back and says, yes, in fact, this has a critical double free vulnerability, whatever that is. I could click this link, find out more about it. But it's saying this was fixed in this version. And all of these pretty much have fixed things because this is a pretty old image. But what's more interesting to me as a container developer is that if I come down here, we're seeing I've detected your on base image Tomcat 8521, which is right. And we know that that image itself has 711 vulnerabilities coming along for the ride just by using that as your base. 65 of them are critical. Now, as I said earlier, 8521 is hella old. But this can happen though, because a lot of times you'll containerize something, you put it out there, and if it ain't broke, don't fix it, right? You just keep running with it. Well, the vulnerability database is never quiet. It's always being updated multiple times a day, and you want to stay on top of that. In this case, there have been many versions of Tomcat since then, and it's recommending that if we want to upgrade to a minor image version update of .64. That would drop our vulnerability counts greatly, including down to 12 criticals. We could also, if we want to get down to 0 criticals, go to a major upgrade. If we can go to Tomcat 10, 10.1 in this case, we'll go to there. Or if we want to get crazy and go with the Amazon Corretto JVM builds, we can get down to 0 known vulnerabilities. Now, 0 vulnerabilities is admirable. If you can get to it, that's great. Usually, most official open source images are going to have some. They're going to have an occasional medium or low that just nobody's taken the time to fix yet, and or there is no fix for it. And this is where, looking through the list, there's other views on this you can take that if we have time at the end, I'll show you, where you can see prioritized lists of, hey, this vulnerability is not only has a fix for it, which means you should go ahead and get it, but it's being talked about on Twitter right now. So our vulnerability database has priorities that can rank those for you and help you prioritize what's to be fixed. But the interesting thing about this is, even as a junior developer, if I don't know anything about middleware, I don't know about Tomcat, I can take this to my lead engineer, my architect, my security analyst, and say, hey, this is what I'm seeing. It's recommending we upgrade. What do you guys think? And my lead developer can come back and she might say, oh, well, we're not ready to fully regress against Tomcat 10 yet. I'm pretty sure we have API errors if we do that. So let's go ahead and take the minor upgrade now, and we will put on the backlog to get on a newer version or to take a look at the Corretto versions because maybe we're stuck to JDK 8 and we don't want to go to whatever JDK Tomcat 10 is on. So those kind of conversations can now be had proactively, right as I'm working on a bug in the app. I do I'm doing my smoke build. I'm doing my container build locally to test it out. I can see it right here. So let's do that. I'm going to go back over here, kill my compose run. And just to be tidy, I'm going to remove the containers that are behind it.
Hey, Eric,
And
sorry to interrupt. I'm gonna keep popping in, being that it's a live stream, and ask some questions, and
sure,
folks
go
have
for it.
questions in the chat too. So I know you've heard me ask this of you before, I think during like an office hours that we've done too, but it's really interesting to me. This is the first time I've seen, as I've been learning more about container security, this is the first time I've seen any images suggested that have 0 vulnerabilities.
Yeah, it
So
actually is pretty
that's
rare.
pretty awesome.
I'm not so I haven't been an active Java developer like for my job in years. So I'm not up to speed on Corretto. I need to research it some more.
Okay.
It is a different JVM. And a lot of shops are, you will have a mandate to stay on OpenJDK or Sun JDK.
Mm.
Sun. I showed my age. Oracle JDK. Um, that's a blast from the past. But yeah, seeing 0 is impressive because what that tells me is that they've really focused on it and they've whittled that image down to the bare minimums, which we'll talk about in a moment.
So, and again, not to throw you off too much, but for folks that maybe don't know, a lot of times, so you saying that that's a rare, or not as frequent that that's happened where there's images available with 0 vulnerabilities. What should be the approach that people take? And it sounds like I know you kind of answered it, but just really emphasize this to help folks out that are new. The approach to take to help get to a secure container, I guess. Like how do they get to that point if they're trying to
Yeah.
reach that noble achievement of 0 vulnerabilities?
Yep. You're seeing one of the joys right now of Docker users on M1. I've run into a base image that doesn't have an ARM build right now, so I'm not
Oh,
gonna
yeah, yeah.
trust me. If I was on my Intel Mac, which is sitting over there, I would be able to rebuild this right now, and it would work. And you would see that I wouldn't be able to anymore do that remote code execution. So we're gonna skip that portion of this for a second. But to address the question, so um, when you get an image that has, let's say, 5 medium vulnerabilities, and there's no recommendation for a better one. Uh, the uh, the reason the thing you want to pay attention to there is, did I add any of those vulnerabilities to it myself? And there's flags you can add to the Snyk scanner actually to say ignore base image vulns. So we'll just show you things that you've done, packages you've added that are doing vulnerabilities. And if there are none, that's the time where you have that conversation. It's like, well, this is what the open source community has for us. And unless we're willing to go in and patch things out of it and turn into a base image owning organization, most places will just say we're willing to live with what is here and have mitigations for these errors. And you can actually hide them. So let's say you had uh, one high vulnerability, because usually the mediums and lows people don't care as much about.
Mm.
You got a high, and that legitimately raises a concern. You can, in the Snyk tools, you can say, we have looked at this, and for the next 45 days, we are going to ignore it because we have mitigating compensating controls based on the firewalls we do, or we don't use the dependency in that library that it's causing this. And you can flag that right in the tool, and people can see that and say, oh, and after 45 days, you can make it indefinite if you want, but it
Mm.
will come back and start erroring again to remind you, hey, you said you were going to ignore this. You should go check and see if it's got a fix now. So there's different, it's really up to the risk tolerance of the team that's using it. But striving for 0 vulns is admirable. I just unless you're doing something for any of the larger images, the Javas, the Pythons, that's a stretch to get to 0. Now, some languages lend themselves to it. So if you've got a compiled language like Go, it's very easy to get 0 vulns there because you can compile down to a single static binary, and then your final stage of your build is just that binary. You can use what they call the scratch base, which is an empty file system,
Mm.
and it has nothing else in it. There's reasons you might or not want to do that, but that is as about as clean as you can get. provided you're scanning your Go code to make sure your
Right.
code itself is clean and the libraries in it.
Yeah. No, that's super helpful, and thank you for answering that. So,
No, no
and
problem.
when it comes to, and one more follow-up to that in the same
Mhm.
context here. When it comes to, it's, coming from my experience with the open source side of things, working in JavaScript ecosystem. One, I know you keep mentioning that it's like a noble thing, but I find it fun in my own like open source projects to try and get to zero vulnerabilities. Unfortunately, in the ones basically when it's just focused on open source and I'm not using like a container for that project, I'm able to achieve that and it feels good. Like it's an awesome, fun thing to like strive for.
Right.
But for ones that I do have containers involved with it, I find it to be a struggle. But I wonder though, in the same way that like with open source, where open source, depending on the support of that open source library, depending on how frequently the maintainers and contributors are publishing releases to it, it could take time. And
Mhm.
we've even seen that when vulnerabilities are disclosed, it could take like a year before it even gets patched, kind of thing.
Yeah.
Have in your experience when it comes to the containers, is that kind of part of the cause, what's
Yeah.
factoring into this, that
Yeah.
these images are still vulnerable?
Yeah, and the reason is because you're now back to my original points. You're expanding your scope from your Node.js application to the operating system distribution that is contained in that image now. That
Yeah.
the bigger orbit, if you will, around it. Um, and there are options, and I have a couple slides that'll get into a little bit about this.
Okay.
So I'll reserve my answering until the end on that one, and see if there's any follow up we want to do on it.
Sounds
How's
good
that?
to me. All right. I'll get out of the way then. I'll
No
stop slowing you
worries.
down.
No, that's good. Great. It's a great point, and it's one that I get asked a lot. So it's great.
And
So
just a couple comments from the chat too.
mhm,
One, where was it? Robert Tables mentions that all this is looking super cool. Love seeing that example code. Just words of encouragement for you that people appreciating what you're sharing. And then Martin in chat was saying you probably need to make some more sacrifices to the demo gods in order to
yeah,
get that
yeah,
to,
yeah.
you know.
This is one of those things that I've been on M1 Mac, and it's amazing, but every once in a while, the reason why I asked Snyk to give me the M1 was this, because we run into this a lot where um, containers have an image has kind of hidden from you, usually if you're not dealing with this, multiple architectures built around. You have the ARM one, the AMD one. You could have Z system mainframe ones. And when you're developing on M1 now, because a lot of developers you run on MacBooks, and all the new ones are M1s, you're going
Yeah.
to run into this. So I'm trying to make sure I have handling for this. The only reason I don't have time on this call to resolve it. I can resolve it very easily by just doing a Docker build with a dash dash platform on it. I have the experimental stuff turned on that'll do that, and it'll run a little QEMU VM in the background to make it work. But with Docker Compose, that's a little more annoying, and I just don't have time in the demo to get to it. So,
Gotcha.
although the amount of talking I've done about it, I'll probably get it done.
Sure. All right. Let's proceed.
So back to, when we look at, this is our normal view of a CD pipeline. I love the DevOps style of this, though, the infinite loop. As you are developing these things, and as I said, you may have made this Tomcat 8521 build 2 years ago, and then it's just worked. And if it ain't broke, don't fix it. Well, that doesn't work really, because in the infinite loop that is real world software development, vulnerabilities are being found all the time. And one of the cool things that our tools will do and even if you're not using our tools, you should do yourself, is it will automatically, let's say I've scanned that image and it's clean today. Well, tomorrow it's not. We will automatically, every 24 hours, if you are using the monitor side of the house on this, which is also part of the free tools, it will rescan every 24 hours and let you know, is that bill of materials you shipped out there, is that still secure? Has it changed? And if it has changed, you get an email. You can even have it set up to automatically, if you're on a public repository, it'll open a pull request for you. And you wake up in the morning to a pull request from the Snyk system with a nice formatted description that says, your version of this has a new vulnerability has been found, and a newer version of the base image is available. Here's the patch to your Docker file to make that change. It'll show the from line being changed. It's really slick. So you want to think about that infinite CD pipeline, not the I'm in production, done, let's go have margaritas. So what do we do about these things in at runtime in real life. Vulnerability scanning is great and finding the issue is great, but let's think about Log4j, Spring for Shell, which is a horrible name, but whatever. These things that come up and there is no fix right away for them. That's or if it's a 0 day, you don't even know about it. How can you do things that can help defend against both the things I've been talking about as well as those unknown unknowns, right? And so we want to practice defense in depth. So the first part of this would be your images that you're building. You want to minimize footprint. And I was alluding to this when I was talking about one of the nice things about Go or the C++ or even Python, you could do this. Compile down to a single binary. Well, that's drastic, but make sure your images are only including the things you need at runtime. The image I was using, Tomcat 8.5, whatever, that's what we call a general image. It's got a ton of stuff in there. As you saw, it had curl in there. I don't need curl at runtime. My application doesn't use curl at any time. So why do I include it? If I were to choose one of the slim tagged images, there's a bunch of most open source official builds have a slim version where they pair off everything but just what's needed to run, in this case, Tomcat. Those curls not there. The kitchen sink and everything else is not there. Last time I looked, I think the image size drops from somewhere in the 800 or 900 megabyte down to 100 and something megabyte. Don't quote me on that, but it's hundreds of megabytes difference between those two versions. There's also distributions like Alpine, which as a base is it's made to be a very small footprint and security focused image. A lot of the Alpine images do approach or hit zero vulnerabilities. The only negative to Alpine, in my opinion, is it is technically, it's kind of like a different OS. It is built on muscle C instead of glibc. So if you have any binary dependencies, such as if you're doing a JNI call, or if you are including a C library of some kind, that also has to be compiled for Alpine, or else it won't work. So you have to keep that in mind. It also is a different packaging system, so it's maybe different than what your organization is used to. It also is BusyBox based, which has some licensing concerns for some people because they're fairly litigious and protective of their IP. So those things come in mind. There's also Google has distroless images, which are Debian based, so they're glibc and all that, but they pare down everything. They are like the JDK that comes from the distroless folks is the JVM, and that's it. There's no shell. There's no package managers. There's nothing else in there. These are really nice as long as that's all you need. So if you don't need any other bell or whistle, take a look at distroless. One negative, depending who you ask, negative side of them is they do not do tags on images, the semantic versioning on images, like the 8521 you saw. They don't do that. They always are, JDK 8. And they're always giving the latest every time you pull it. It's a mutating tag. It's always following. Just like if I did Tomcat 8, it would always give me the latest version of Tomcat 8 by convention. This is great if you're a CD shop that's pushing out, build after build after build. That might be fine. But if you want a reproducible build for a given commit in your repository, you want to always be able to guarantee you're getting the same one back. You really should. You want to have images that are tagged to a more specific, at least the semver, if not the full hash of the image, to make sure you have a reproducible build. I'm kind of bleeding into my build strategies here, but main point here is use the smallest image that you possibly can for your application. So you're not giving hackers tools to beat you over the head with, right? You don't want them to be exploiting things based on tools that you gave them.
Hey, Eric, question for you from the chat.
Mhm.
Robert Tables asks, do you recommend using images with bells and whistles for active development and debugging, and then later switch to the slimmed down image for Q&A production?
I'm totally cool with that. I absolutely love that. And the danger there is that you'll check in that version. So you just got to make sure you practice good housekeeping around that. One of the things in fact, if you watch my Docker pitch for my talk at DockerCon, I show a way in running desktop Kubernetes to use customize to make that life a little easier for you, and without worrying about committing things that you don't want to commit. But that aside, yes, that's kind of what I think those images are for, is for the experimental, iterative, local development process, where you don't want to have to worry about, crap, I got to edit my Docker file just to add this thing now. Just Let me work, and then when I'm ready to commit, we'll pare it down to the small version. This is also where multi-stage builds are great, because if I need a whole bunch of tools to build my software, but I only need a couple things to run it, you can do the 2 stages that way, which is kind of what we're doing here.
Mm.
Not great. We could be doing more, but at least in my example, that allow you to have the tools you need to build. But if you need to be able to troubleshoot and whatnot, doing that locally is totally makes sense.
Excellent. Thank you, Robert Tables, for the question.
Yep.
All
Um, when I say layer housekeeping, this is just, if you're not familiar with how Docker images work and what how the layers lay on top of each other, do a little studying up on that. Go look at the Docker docs on it. It's not complicated really, but it is good to know. For instance, if in this example I wanted curl to be gone, I could do run rm user bin curl wherever it lives, and that would kind of work, but not really, because all it's doing is it's adding a layer to the image that says hide that file. If there is if somebody were to exploit your image in some other way, and heaven forbid you bind mounted the host volume into that container, or the var volume into that container, on, or somebody else did, of course you would do that. If you're root in that container and you've got a mount into /var, you have /var /run/docker. So, you can get all the way down into the container layers and the image layers, and you can find anything that somebody has removed. So really, RMing something in a layer doesn't really get rid of it. You want to start from a clean slate, and that's where, again, multi-stage build is great, because you can start from a tiny one and then just bring in the pieces you need. I've talked build strategy all throughout this. Multi-stage is great. Repeatable builds I'm a fan of, especially in an enterprise setting, because oftentimes for audit, you need to be able to have reproducible builds based on a given version control commit. Standardized labeling. Docker label is the most underused cool thing in images, in my opinion. There are a bunch of standardized OCI image annotations that you can use that allow you to have metadata attached to your image that isn't really used for runtime. It's more for informational purposes. Take a look at it. I'm running low on time, so I'm going to get moving here. And there's alternative tools. If you're doing Java builds, you might not even want to use Docker build. Maybe you want to use Jib, which is an open source, another Google project. Complete 100% JVM based image builder that you can pack right into your Maven or Gradle script, and it will produce a image that will drop to whatever registry you pointed at, or into your local Docker if you have Docker. But you don't need Docker to build your image with some of these tools. So Jib, if you're a Go developer, Co is very popular. Canico is very popular if you're using a Kubernetes based CI/CD chain. A lot of other tools out there, BuildPacks, Kpack. Take a look at those if they fit your needs. If you're on OpenShift, you're probably using Builda. There are different ways to build things with Builda, but know that. And secure supply chain there are conferences now dedicated to secure supply chain. So all I'm bringing it up here for is you need to know where your images come from. Don't be deploying random image that Eric built on his laptop to your servers, because you have no audit trail behind what I did to make that image. You want to have control. You want to have managed registries. You want to have your own managed registries. Don't just deploy from random ECR repo out there from vendors. You want to get your images from whoever, vet them, make sure they are the ones you want. You could even use Docker Contest Trust if you're willing to learn Notary. And there's other signing things I have no time to talk about right now. But make sure you know where your images are coming from, and they should be coming from CI or some kind of automation that is auditable. At runtime, don't run as root. You very likely don't need to be running as root in your container. Most official images default to root because that's what images default to, but often they will include a user. So Node.js, for instance, the node, the official image has a node user that's UID 1001. And at the end of your Docker file, you can say user to set the new default to that user. And now the default for it will not be root anymore. You probably also should tell your runtime engine, whether it's Kubernetes or anything else, to not run as root. And there's a flag we'll talk about when we get to Kubernetes about how to do that. But as root, you are UID 0. You have elevated privileges. And yes, there are user namespaces and other cutting edge things that nobody are not very popular yet because they're so new. The default least common denominator of deployment states you shouldn't be root. If you want to know more about that, look at Liz Rice's container security book. She goes into a great whole chapter on it. Privileged containers are bad for anyone other than writing very low-level things that are doing like Kubernetes low-level monitoring or network interface stuff. Basically gives you access to the devices on the host. So you're God on the box. You don't want to give privileged containers. Start with those. You also don't want to have, no, we'll go with that. Linux capabilities, which are the ability for a process to get limited elevated privilege on certain aspects. Most business applications don't need many of these, if any. So I would try. I like to drop all Linux capabilities, and then if I have a problem with an app, then I can use tools like Tracy or strace or whatever to figure out. There's blogs written on this. What capabilities, how to figure out what capabilities you need, but you probably don't need any for business applications. The read-only root file system. You can tell Docker when it starts a container up not to build that read-write layer that sits above the image. So when you start a container, images are read-only technically, and any mutations happening are actually being done with a copy on write. It's bringing the bits up into this read-write layer and modifying it there. You can say don't start that read-write layer, and now you have a read-only file system, aside from whatever volumes you might mount yourself. By doing that, you make life harder on the hacker because he can no longer modify the file system. You're being a good 12-factor app because you're immutable. It makes it easier for your application to be scheduled in an orchestrator. All sorts of good things happen when you make your file system read-only. And then, like I said before, deploy from only known sources. If you're running Kubernetes, which you probably are, if you have credentials, connection strings, any kind of secret type data, either use an external vault type thing like HashiCorp Vault or CyberArk or one of those tools. If you're already using it, great, continue to use that. Or use Kubernetes secrets and use RBAC to protect them. And make sure your cluster ops are encrypting your Kubernetes secrets at rest. If you're in the cloud, you probably are getting that by default. But if you roll your own Kubernetes clusters, by default, secrets are stored in etcd in base64 plain text, basically. Don't do that. But by using secrets, instead of putting credentials in your image, which is horrible, or in some kind of flat file that you're just going to attach on, that's not secure, not safe. Use Kubernetes secrets, or if you're doing Docker Swarm, use Docker secrets. Use RBAC, use role-based access control. Hopefully everybody is using that if you're on Kubernetes. And the security context. This is the APIs that Kubernetes gives you around the pod, and there's some for the container that do a lot of things I mentioned on the prior slide. Restricting containers to not be able to run as root. Setting what user you want them to run as, or setting the root file system to read-only. All those kinds of things can be applied by the security context. You should be using them. Network policies. This is how you limit pod communication on the network. By default, in a Kubernetes cluster, pods are guaranteed to be able to talk to each other with no NAT, with no restrictions. Network policy comes in to allow you to add restrictions. It's kind of like a microsegmented firewall, if you will, that based on what network plugin your Kubernetes provides has more, has different features. But what it comes down to, as a developer, I look at that, I'm like, oh, complicated firewalls. It's not really. It's just basically saying, here's what I want. I know my front end needs to talk to my database. But my database never needs to talk to my front end, and my front ends don't need to talk to each other. So I can set that up easily by tagging and say, hey, allow this kind of traffic, but not that. I'm a fan of the zero trust policy, where I basically set for my deployment, for my namespace, nobody can talk to anybody except for those rules I just kind of talked about. This kind of traffic is the only thing I allow. So it's an allow list kind of a thing. You can say deny all and then allow. If you do that, make sure you include DNS as your allow, because if you don't, you'll have no service discovery in your Kubernetes cluster. That's bad. And finally, all of these things I'm talking about can be enforced and mutated at deployment time with tools like, you could do it with pod security policy, but that's deprecated and being replaced by pod security admission, which I believe is in beta in the current in 125. Don't quote me on the version. But a lot of people have gravitated now to OPA with the Gatekeeper admission controller or Kyverno. Both are excellent tools. Admission controller is something in Kubernetes that watches all the API calls coming in and any deployments coming in that it can say yay or nay, or it can actually mutate them as they come in. So you could apply read-only root file systems if you wanted to every container and let them break as they will. So finally, key takeaways. Sorry, I'm running long. You want, going back to our original discussion, you want the fast feedback loop of moving security as far left as you can, so the developer is getting that feedback immediately or as close to as immediate as possible. Our tools, we actually have IDE plugins to help show you things both in code as well as some of the IAC scanning we do and some of the container scanning we do. So take a look at JetBrains or VS Code users, take a look at those plugins, but the CLI tool will do all of it. It's all free. Empower developers to be productive. So that you want that tool to give information that is useful, not just a big spreadsheet of errors. And then finally, practice defense in depth. All the things I'm talking about help minimize the blast radius should something happen, slip through these prior checks. And with that, here's a bunch of links to things, including this. I've done a bunch of videos on last year on the security contexts, and we did a cheat sheet on that that is at the top here. To look at those. And again, I will post these slides on my Twitter account, which is Eric Smalling, shortly after this is over today. And with that, do we have any other QAs that have come up?
No, not that I've seen, but lots of great feedback in the chat from folks appreciating you sharing your expertise and describing things the way you have. They're going to pass it along to their own team so that they can check it out. Yeah. So yeah, thanks everybody for joining in on this Stranger Danger session for Snyk Live. Thank you, Eric, for helping us out, learning more about why we as developers should care about container security. Little housekeeping things for folks. If you enjoy these live streams, be sure to follow, or if you're on Twitch, follow and turn on notifications if you care about having notifications on. Otherwise, turn them off because you will get notified when we go live. In addition to that, if you're on YouTube or you're watching this later and you enjoyed it, like the video and subscribe, please, so that you can get more if you do enjoy all this fun stuff. And if you want to join in for more live streams in the future, which doing those things will help you get that. But if you want to see the schedule, we have a calendar that actually, this is my bad. I got to add the link into the channel description, but we have a calendar. But to give you a heads up, starting in May next week, we're going to be doing, I know this is a little bit off topic because it's not Java related, but JavaScript related streams. We're going to just kind of swarm you with JavaScript related streams, JavaScript trivia, JavaScript like panels with folks, more stranger dangers like this. All kinds of fun stuff is coming up in May here on the Snyk Live channel. So be sure to tune in for that if you are interested, and we hope to see you there. Thanks again, everybody. Have a good rest of your day wherever you are in the world. Thank you, Eric, again. Any closing words from you?
No, thanks. And like I said, hit me up on the social. Oh, devseccon.com. We have a Discord server. Go there.
Yes.
That's our community Discord server. If you go to devseccon.com, click on join the discussion. I think is the link. And if you don't have Discord already, it'll help you set up an account. And if not, you'll jump in. And I'm in there. I'm probably Smalls. That's kind of what I am in most Slacks and Discords. But,
You're killing me, Smalls.
That's my call.
There it is. Thank you for that reminder, Eric. All right. Thanks, everybody. Have a good one. We'll see you next time. Adios.